Welcome back. There's a new approach to RAG getting attention. No chunking, no vector database. It's called Vectorless RAG. Let's dig in. And if you haven't seen the 6-part RAG series, link in the description. Let's start with reviewing traditional RAG using our fictional company TechVault. Here's their employee handbook. 40 pages, 3 levels deep. Every chapter, section and subsection in exactly the right place. This structure matters. When you need the expense approval policy, you don't search section 1. You go to 3.2. The structure tells you where to look. Now, this is the standard chunker. 500 tokens. Doesn't care where a section ends. Every chunk loses its place in the document. They all look the same to the vector database. And this isn't unique to fixed chunking, semantic, sentence, paragraph. We covered all of them. Same ceiling. A chunk has no idea where it sits. These chunks go into the vector database. Now let's look at query side. Someone asks what approval is required for expenses over $500. The question gets converted to vector and sent to vector DB, which returns top results. The similarity search finds the closest match. This is sent to LLM as context along with original query. Answer returned was section 3.1. Expense categories. Same topic. Wrong answer. The problem isn't retrieval. It's that we destroyed the document structure before we even started. Without structural context, the retriever picks the wrong section rather than the correct answer. Here's how Vectorless RAG handles the same handbook. Same document, full hierarchy intact. Instead of a chunker, we hand the whole document to an LLM with a simple instruction. Let's look at that more closely. The document is sent to LLM with a prompt to return a YAML summary with IDs, titles, and one-sentence summaries for each section. In response back comes a structured YAML tree. Every section gets an ID, a title, and a one-sentence summary. This is the document that we will search in query to derive answers. Now coming back to our original flow, the return result gets saved to disk, a plain file. No embedding model, no vector database. Now the query side. Someone asks what approval is required for expenses over $500. We send the query to the LLM along with the summary tree from disk. Let's see exactly what that looks like. The document is sent to LLM along with the user query asking it to return the ID that are most likely to contain the answer. LLM responds back with the specific section. Node 3.2. Now back to query pipeline. The LLM looked at the titles and summaries and pointed straight to the expense approval section. We pulled just that section from disk. Send the full text to the LLM. Expenses over $500 require manager approval. Amounts above $2,000 require VP sign-off. Exact. First try. The LLM reads the map and picks the right section. No embeddings needed. Let's map this back to the familiar pipeline. Document comes in. Chunker processes it. Vector database stores the embeddings. Vectorless RAG makes 2 swaps on the indexing side. The chunker becomes an LLM indexer. The vector database becomes a file on disk. On the query side, the embedder, vector search, and top K are replaced by a single LLM navigator. Same structural pipeline, smarter components. TechVault now has 7 retrieval systems to choose from, built one by one across this series. Next, we step back and map the entire RAG landscape. Every approach organized into a taxonomy. See you in that video.